Okay, we're going to go to one of my favorite topics, which is the idea of launching stuff in the air. We're going to start with this soccer ball here, and we're going to be launching it. Let's just say that the ground is right here, and we're going to launch it from the ground. Okay, and we're going to fire it up in the air. Just to get started here, let's say it's going to go 10 feet per second. Okay, so 20 feet every second. Okay, which means after 1 second, you would expect it to be 20 feet in the air. And then after 2 seconds, you'd expect it to be 40 feet in the air. Okay, so that was 1 second and 2 seconds. Well, how about 3 seconds? Well, you can imagine it's going to be probably 60 feet in the air. It's going to go up here somewhere, and let's just say it's 60 feet. Now, your brain might be going, just a minute here. Isn't the ball going to eventually start falling back down? Okay, because if it keeps going, 1 second, 2 seconds, 3 seconds, 4 seconds, you could say, well, shoot, shouldn't you be able to take the number of seconds times 20, and that would be the height? So let's try it. Let's say after 8 seconds times 20, it would be 160 feet in the air. Okay, well, I don't know about you, but I'm pretty confident I can't throw a ball 160 feet in the air, and it's definitely not going to be up there for 8 seconds. If I just launch it up in the air, it's going to fall back down. So, yeah, you might notice that for now, we're sort of avoiding gravity. We're pretending gravity doesn't exist. So, so we can do that, though, for just a bit. Let's just pretend it doesn't. It's not happening. So let's come back here to the ground level. Start again at 0, and let's now launch it at 40 feet per second. Okay. Well, after 1 second, it's going to be 40 feet. After 2 seconds, it's going to be at 80 feet. And you can imagine after 3 seconds, it'll be at 40 more, so 120. So what we could do is simply say, take the number of seconds and multiply it by 40. Okay? No problem. So all we have to do is take 40 times the number of seconds, and we've got our height. So basically, what you're telling me is that if you take the speed you're going to throw it up there, let's say it's v for velocity. Basically, we're going to take v times time, okay, the velocity 40 times the number of seconds, the time, and that's going to give us the height. Okay? So that should work pretty nicely. In fact, let's just write that right up here. Height equals velocity times time. Okay? So we've got that figured out, but I'm going to throw something else into here. Okay? I'm going to say, hey, guess what? Let's start the thing from a building. We'll start up here. And let's say the building is 100 feet tall. Okay, and let's fire it back up in the air, say at 20 feet per second. Okay, so after 1 second, it's gone 20 feet, except it was already 100 feet to start with. Okay, and then after 2 seconds, it will have gone 40 feet, except it was 100 feet to start with. So now what we're going to have to do is say, apparently, we need to take the 20 times the number of seconds and add 100 to it. So if we were going to find it out for, say, 6 seconds, we'd say, okay, no problem. We'll go 6 times 20, but we got to add on 100 here. Okay, so it looks like for our height equation, we need to add 100. Okay, so it's going to be the initial velocity times time plus 100. In fact, I think what I'll do is this. Let's say we're just going to say, I don't want to use h. let's say starting amount. Starting height. Okay? So what we're going to have to do then is add on our starting height every time we multiply the speed times the time. Okay? So let's clear all this here and say, you know, so far I think we're good. We know how high the thing is going to be after any number of seconds. So I could come along here and say, tell you what, let's start from a tower that's 30 feet tall, and let's launch it up in the air at 50 feet per second. And we'll be able to find out how high it is after any number of seconds. So let's say we go for 12 seconds. No problem. We're going to take 50 times 12. That's the speed, number of feet every second, times the number of seconds. And then we'll add 30 on. Okay? So that's fitting this pattern up here. We've got the initial velocity times the time, okay, plus the starting height. Okay? So, working out okay. There's a bit of a problem. You're not going to find a place that doesn't have any gravity. Not going to find it easily anyway. Okay? So it looks like we got to fix our equation somehow. Well, it turns out there's a nice way to fix it. Okay? I'm going to write it this way to start out with. I'm going to write H equals V0t plus H0. And all this 0 means is the velocity when it first starts, time equals 0, and the height when it first starts, time equals 0. Some people say, think of it as an O for original. It's the original velocity and the original height. Okay, so as you know, I'm going to fire this ball up in the air, but pretty soon it's going to slow down and fall back down to the earth. Okay, so let's try it again. Starts here, we launch it up in the air, and eventually falls back down. So what's happening, as you know, gravity. Gravity is pulling downward on this ball, eventually slows it down, and makes it fall back downward. So essentially, gravity is subtracting height away. Okay? And it turns out that Mr. Isaac Newton has helped us figure this out. He says, look, here's how much height gravity steals. Okay? So whatever your height would have been without gravity, now this takes away some gravity. And you could think of it this way. Because time is being squared, it has a bigger and bigger effect as it gets bigger. You know, if time is a tenth of a second squared isn't very big, even if you multiply it by 16. But when time gets to 5 squared is 25. 25 times 16 is a fairly big number. If time gets to 10 seconds, 10 times 100, or 10 times 10 is 100. 16 times 100, that's a really big effect. It's subtracted a lot of height. So this is our equation that allows us to find the height of any projectile, anything we fire up in the air. Although I'm going to write it this way. Negative 16 t squared plus v0t plus h0. Okay. By the way, the 16 only applies on the surface of the Earth. Okay. If you were on Jupiter, it'd be a lot bigger. If you were on the Moon, it'd be a lot smaller. Okay. This is the initial velocity. You probably recognize that the velocity changes right away. As soon as you fire it, the velocity starts decreasing, and then it goes to 0, and then actually becomes negative. It starts pulling back down. So that's only the starting velocity, and then this is the initial height. Oops. Initial height. Okay, so we're going to use this thing here. Now that we've got this nice equation, we're going to use it. So I've got a problem here that says an object is launched from a 30-foot platform into the air with an initial upward velocity of 400 feet per second. write an equation to represent the height of the projectile y seconds, the height of the projectile y after x seconds. So I'm going to copy our equation down here that we had from before. H equals negative 16t squared plus v0t plus h0. Okay. But they want me to use y for the height, so we'll replace the h with y. They want me to use x for the number of seconds, and we'll replace the t with an x. So the minus 16, it didn't say, but we're assuming this is on the Earth, so minus 16x squared. What's the initial velocity? Well, 400 feet per second. So we'll just have plus 400. Again, we're going to replace the t with an x. And then what's the initial height? Well, it's launched from a 30-foot platform. So, we'll write plus 30. And there we have it. We've written our equation to represent the height of the projectile y after x seconds. Okay? Now, find the height of the projectile after 10 seconds. Well, this equation is going to answer this for us. It's basically a recipe for the height when I know the time in seconds. So here I go. I'll just put this 10 in for x in both places. Negative 16 times 10 squared plus 400 times 10 plus 30. And now we'll just grab a calculator and calculate that up. I have an on-screen calculator I can use here. So here I go. 16, make it negative, times 10 squared plus 400 times 10 plus 30. It's a scientific calculator, so it will do all of the squaring first, then the multiplying, then the adding. And I got my answer of 2,430 feet. 2,430 feet. Okay? And we've shown our work here well enough to be able to demonstrate that we know what we're talking about here. Okay, let's go to the next problem. Okay? Now I've got a missile that's launched from a pit. A pit is a hole in the ground, right? It's 20 feet deep with an initial velocity of 250. Okay? Write an equation to represent the height of the missile after x seconds. So we know it's going to look like this. Y equals negative 16x squared plus v0x plus h0. And we'll just toss the numbers in the right places. It's on the surface of the Earth, so we'll use minus 16x squared. The initial velocity is 250 times x. And the initial height is what? 20 feet, except it's not a 20-foot tower, it's a 20-foot pit. So we're just going to make that a minus 20. And now we've got our equation. Okay. Negative 16x squared came from the fact that it's on the surface of the Earth. The 250 is the initial velocity times x minus the initial height, because it's a pit, it's a hole in the ground. Then it wants us to find the height of the missile after 6 seconds. So all we have to do is take this 6 and we put it in for x in both places. So negative 16 times 6 squared plus 250 times 6 minus 20. Again, grab the calculator. We got 16, make it negative, times 6 squared is 36. I can do that in my head. Plus 250 times 6 minus 20. Press equals. We've got 904 feet. Okay, got one more. This one is dropped. Okay, notice that dropped means it has an initial velocity of 0. It's not going up, it's not going down when you first drop it. So we're going to have y equals our negative 16x squared again. That's gravity pulling down, plus 0x, and then it dropped from a height of 2,650 feet. Okay? Oftentimes we don't even bother writing that. We'll just write negative 16x squared plus 2,650. And then the same thing. We want to know after 3 seconds, so we'll just put a 3 in for x. So negative 16 times 3 squared plus 2,650. Calculate up, and we've got our answer. 16 times 9 plus 2,650 equals 2506. 2,506 feet.